स्टार्ट झाला का? वेलकम स्टूडेंट. Welcome student to yet another lecture of trigonometry. This is a weekend. So we are going to take a problem which is, as per the textbooks, they say it is of hot level or D level, somewhat understood as a tough problem. So if you try to listen to this lecture very clearly, you will find problems are actually very easy. Only it depends whether the length is more or less. So this is a fourth problem which we are going to discuss of the show that section. Now, as usual, whenever we start the problem on the right hand side or on your table, you must have the formula list. So the formula list is there. Now take the problem. The problem is on your screen. So it is prove cos A minus sin A plus 1 divided by cos A plus sin A minus 1 equals cosec A plus cot A. Now what is the importance of this problem? That in the numerator and the denominator, you have somewhat similar ratio with sign difference. Again listen, you have similar ratios with sign difference, that is cos cos, sin sin, and then we have numbers. So we know that now this ratios, try to connect it with the right hand side. Right hand side is given to you as cos A plus cot A. Now how you can convert the left hand side ratio in cos A and cot A? Again, there are three terms given in the numerator, 3 terms in the denominator. So what you have to do is that try to get out some way that you can convert cos A into cosec A or some other ratio. Now this cot can be easily converted in sin and cos, and cosec A can be converted in 1 upon sin. So we'll have the formula here on the screen. So here it is, cot A is cos A upon sin A, and cosec A is equal to 1 upon sin A. So you will find that in both of them we have sign in the denominator. So focus on the sign in the denominator, that is sin A and sin A. Okay, so what we will do, now there are 6 terms, cos A, sin A, 1, again in the denominator cos A, sin A and 1. So now we will try to divide the term by sin A. Okay, so before that, just take down the left hand side. So your left hand side is there. Make the necessary changes in the color, or I am making some color change. So observe that, you'll get it here. Then I will try to put some brackets here. Cos A sin A, cos A plus sin A. So the two ratios, plus 1 is separated out in the numerator and minus 1 is separated out in the denominator. So now look that. So it will be, so it is, I have not taken that part. So here I have directly replaced, this each and every term is divided by sin A. So take it down, cos A sin A plus 1 and cos A plus sin A minus 1. So all the 6 terms are divided by sin A. So now on dividing by sin A, here cos A sin A, this will get converted in cot. This will get converted in 1, sin A divided by sin A, and this 1 by sin A, it will get converted in cosec. Okay, similarly, in the denominator also this cos A upon sin A will get converted in cot, then sin A and sin A, it will divide and get converted in 1, and this 1 upon sin A, again it will get converted in cosec. So now look at the step how it is. So cot A, this ratio cos A upon sin A is now becoming cot A. So I'll show you with the marker. So focus on this. So this is your term. Okay. And now this becomes your cot A. Then this sin A divided by sin A, this is becoming this minus 1. Okay, and this 1 upon sin A, now it is becoming this cosec A. Similarly, in the denominator, I'll underline this cos A upon sin A is becoming cot A. Then this division, I'll make a box like structure somewhat. Okay, so this division is becoming 1 here, somewhat like this. And then here 1 upon sec A, this I will take some zigzag line. So this is your zigzag term which is becoming cosec A. Now this step you have to observe very carefully. How we are dividing by sin A or why we are dividing by sin A, and then what is the output by dividing the sin A. Now once you get this step, so here we have applied some formula which has been used here. Then the next step is to reset. So what we have done, cos A is brought close to cot A. So sorry, cosec A is brought near cot A, and this minus 1 is shifted to the last term. Same way we are operating in the denominator, cot A and minus cosec A are brought together and plus 1 is written aside. Now here what we are going to do, this minus 1, I'll make it here pen. So here you have to focus on this minus 1. Now this minus 1 we can replace with the identities in reverse fashion, that is 1 is equal to 3 identities we have seen. See here to here, 1 is equal to reverse, 1 is equal to reverse, and again 1 is equal to reverse. So naturally, as here we are dealing with cot and cosec, so this 1 can be written as cosec square theta minus cot square theta, that is here we will be using in place of theta A. So on writing that, we get cot A as it is, cosec A as it is, and in place of this 1, the minus sign is kept as it is, and 1 is replaced by cosec square A minus cot A. That is, this identity is there, which is there available on the right hand side also. So your 1 is been replaced and the denominator is kept as it is. Now students, after this step you must be very careful. Now here it is cosec square A minus cot square A. Now operate here using the formula A square minus B square. So when you apply that formula, it will be A plus B, A minus B on the right hand side. So here you will have this cosec square A minus cot square A. If you apply the formula A square minus B square, the working is shown here. In place of A, we have cosec square A. In place of B, we are having cot square A. So here it will become cosec A plus cot A, cosec A minus cot A. So this part, so this your part is been now replaced with this application of the formula. So this is a replacement here. Okay. Then cot A plus cosec A is kept as it is. The denominator is kept as it is. Now the next step is very important, because once you get this, and now in this step only try to see, it is cosec A plus cot A. a minus sign here, and on the left side we have cosec A plus cos A. So this bracket and this bracket, they are carrying the same terms. There is no change, only the terms are written here. Cot A is first, having a plus sign. Here cot A is the second term, having the plus sign, whereas here we have cosec A, and same thing we have cosec A, only minus sign. So what we'll do, keeping this minus sign at the center, this bracket and this bracket, we will take it common. So what will remain on the left side of the minus sign is 1, and on the right side this bracket will remain, that is cosec A minus cot A. Denominator kept as it is. So that step is like this. Cot A plus cosec A is taken out common, then this minus sign is there. Show it this minus sign. We keep this minus sign here at the center point. So this is our minus sign. Then when the bracket is taken common, so on the left of the minus sign, no terms are there, therefore we write this red color minus 1, and on the right side, this bracket is remaining. So that is written here, and this is the common bracket which has been taken. So this is your common factor coming from either side of this minus sign. Fine. Now in the next step, once you take common, you can open up this bracket. So once you open this bracket, the minus sign will get multiplied here. I'll use a lighter. So this pointer is there. Minus sign multiplied by this cosec A will become minus cosec A, and then minus sign multiplied with minus cot A will become plus cot A. So this sign will get changed. So okay. So it is now cot A plus cosec A. The outside common factor is kept as it is. Now inside this bracket, so from this bracket to this bracket if you go, so inside this bracket this minus 1 is kept as it is. 1 is kept as it is. The minus sign is multiplied inside the bracket when we get minus cosec A plus cot A. Fine. Now observe this bracket. On opening, you get here this part and then this part. So it is what? 1. Here it is 1, and again in the denominator you will get 1. So here we have, this is 1, this is 1, both are plus. Then we have here minus cosec A. In the denominator we have minus cosec A, and plus cot A. Here also we have in the denominator cot A. So this numerator, which is capped by the red line, and the denominator, they will get cancelled. So on cancellation, what remains is cot A plus cosec A. So that will be written down now here, cot A plus cosec A. Now this is your right hand side, cosec A plus cot A. Thus we have proved that the left hand side is equal to right hand side. Fine. Now what we have to do, the same problem, we will try it by yet another method. So these are the problems which can be done by a number of methods actually, but this problem we will try it by one more method. Therefore we have proved the same problem, solving the same problem by another method. Okay, so we will proceed for that problem. So the problem is on your screen as usual. So now here we are not going to write the formulas here, because I will require more screen to write the problem. So on the left hand side we have here the problem, left hand side as it is. Now we will change the color. So the color change is there. And now here, what will we be doing? That we will try to bracket out cos A minus sin A in numerator as well as in denominator, and this plus 1 in numerator and minus 1 in numerator will be kept separated. So when you bracket it out, so the bracket sign will come here, see that. So here we have cos A minus sin A in bracket plus 1 outside, and then we have here cos A plus sin A in bracket minus 1 aside. What we will do here now, we will treat the numerator bracket this numerator bracket we will take as A. Can you get that A? Oh, sorry, it is not coming up. The denominator bracket we will take also A, and here this second term we will take B. Fine. And now we will try to rationalize it. Now rationalize it, we have seen, bring it back. Okay, here it is. So A minus B. For rationalization it is like this, A minus B. For this, the term is A plus B. If you remember, in our last problem, one of the last problem, we have seen that when we take the conjugate binomial, just we have to change the sign which is in between. So it is A minus B, it will become A plus B, and then this conjugate binomial is taken and multiplied the numerator and the denominator. So what will happen here? This complete denominator, this bracket cos A plus sin A plus 1, the conjugate binomial will be complete denominator with a plus sign here. Now this conjugate binomial is taken and the numerator and the denominator is multiplied. So now this screen will be like this. This is your denominator. This plus minus sign is converted into plus sign. Here it is. So this is a conjugate binomial effect, and whatever is in the denominator, the same thing is written in the numerator, so that the value of the problem doesn't changes. So this is the conjugate binomial of the denominator. So this step we will say rationalizing the denominator. Okay. So now in the next step, what we are going to do is we will multiply the numerators directly, whereas in the denominator, if you just look at that, it is cos A plus sin A. Then this conjugate effect we have taken minus and plus. So we can take this bracket minus 1 bracket plus 1. So it will be A minus 1, A plus 1. So that we can use the formula A square minus B square and write as, A square minus B square we can use it. And then the effect will be like this here. The numerator just multiplied. They are written in this purple brackets, the first numerator, then the second numerator is written in the second bracket. And here we have the effect A plus B, A minus B is A square minus B square. So our A here is the bracket which is written here A square, and our B is 1 and 1 on both the sides, therefore it is minus 1 square. Now after this step, now try to see these terms. There are 3 terms in the first purple bracket. Just mark it here. Okay, so this is your first bracket. Now what we are going to do is that take this cos A and multiply the second bracket. Then take the minus sin A, again multiply the second bracket, and take this plus 1 and again multiply the second bracket. Okay, and in the denominator, you can just remove this 1, and for this cos A plus sin A, you will have A plus B the whole square formula, that is just expand this. So the step I'll write it on the screen. So it will be this way. See here, cos A multiplied by the bracket. So this is your cos A coming here, and we are putting the second bracket as it is. Then you will get this sin A coming here with sin, and again the second bracket. And then we have this plus 1, this is brought here, and again the second bracket. So this way we are going to multiply the numerator and in the denominator cos A plus sin A by using the expansion formula of A plus B the whole square. It is A square minus 2AB plus B square. So here that will take now laser. So it is cos square A plus 2 cos A sin A plus sin square A. So that was the denominator first bracket expansion, and this minus 1 is kept as it is. Now in the next step, quite simple, this cos A which you see here is multiplied inside the bracket, then minus sin A is multiplied inside the bracket, and then this plus 1 is multiplied inside the bracket. So when you multiply this cos A and cos A, you will get cos square A. When you multiply the cos A with sin A, you will get sin A cos A or cos A sin A, you can write anything. And then cos A multiplied with this 1 will become just cos A. Similarly, we will multiply this and this. So the step is on your screen. See here. Now one step, every point I'll explain you. Cos A into cos A will become cos square A. Then cos A into sin A will become cos A sin A, second multiplication. And cos A into 1 will become plus cos A. Now the next multiplication, minus sin A into cos A will become minus sin A cos A. So you have to focus on this sign. Then sin A into sin A, that will become minus sin square A, because minus into plus is minus. And then the last multiplication of this bracket is sin A into 1, that will become minus sin A. And then lastly, just multiplying the plus 1 inside the bracket, there won't be any change because the effect of multiplication by 1 brings no change there. So you'll just get cos A plus sin A plus 1. Fine. Now here I'll just rub it out, this part. Okay, so eraser is gone. Again I'll take the pointer. Now look at this term, cos square A, there is no repetition of cos square A. Then look at this second term, cos A sin A. If you just look at this term, you have a similar term here, sin A cos A. These two terms are exactly similar, but they have opposite sign. So they will get cancelled. Then cos A, again we have plus cos A as it is, so no change can be done in it. And then we have this term, oh sorry, this is not there. Just I'll erase that also. Okay. Take the pen. Then we have here this sin A minus sin A, sorry, sin square, only single term is there, so keep as it is. Now this minus sin A, we have here plus sin A. So these two terms will also get cancelled. So you will find what remains. So here this cos square A is remaining, then this plus cos A is remaining, then we have minus sin square A remaining, we have here cot A remaining, and here we have plus 1 remaining. Now in this, just look at this cos A. I'll put a highlighter there, see whether it is working. See whether you can see this cos A and this cos A. Fine. So now this cos A which is highlighted and this cos A, both are plus, so it will become 2 cos A. Then this cos square A minus sin square A will remain as it is, and this plus will remain as it is. Whereas now come to the denominator. In the denominator, this cos square A and sin square A. This denominator, the cos square A and the cos square A of this denominator, I'll just bring it here, is brought here. Okay, and this plus sin square A, that is brought close to the cos square A, whereas this 2 cos A sin A is just pushed ahead and minus 1 kept as it is. So here you will work with the formula cos square A plus sin square A. We have the identity whose value is 1. Fine. So now these are the changes going to happen. So be careful. So what is going to happen? Cos square A will remain as it is. Sin square A will remain as it is. Then this term will get cancelled. So see what is getting cancelled and what not. So here we have, these are the cancelling effect. Cos A sin A, sin A cos A. Same terms with opposite sign cancelled. Then this we have minus sin A plus sin A cancelled. So what remains is now cos square A, cos A, minus sin A, cos A, again plus 1. And in the denominator we have brought the sin square and cos square term closed, whereas other terms are written ahead. So the effect will be now, only this can be added. It will become 2 cos A, rest everything is as it is, and in the denominator here you will get 1. So here we have cos square A plus 2 cos A minus sin square A plus 1. Now this 1 I have written here, so that also I will point it out. This formula effect, cos square A, here it is, this is your 1 for that. And this 1 is there coming from this side in the denominator. Okay. So this term is brought as it is, so kept as it is. Then this sin square A is kept as it is, and the plus 1 here is the same one from here. Fine. Now these two get added up and that becomes 2 cos A. So the numerator and denominator are explained. Now just see what will the effect. We have here cos square A and this. So this is getting cancelled. So whatever is remaining, that will be written now. So we will divide the screen in 2 parts and write the balance which is from here. So what was the remaining thing? Just come up here. Cos A, 2 cos A. This full numerator was there as it is, and this is get cancelled. So in the denominator what we have, so this cancellation sign is making, so this is a problem here. It has not gone in proper place. So just make the correction. This minus 1 is cancelled with this 1, not the sign. So what remains is 2 cos A sin A. So 2 cos A sin A is remaining, whereas in the numerator what we have done, this minus sin square A. So we have kept the minus sign here. Where is the cursor gone? Oh, got it. So this is a minus sign and this minus sign here. Okay. And then this part of the problem is important. So we are replacing this sin square A, the circle here, with 1 minus cos square A. So use of the identity, which can be written in 2 more forms. Now after this, we will, I'm not able to trace the gun where it is going. Here it is. Okay. So the laser point is here now. So okay. So now just open the bracket. Rest everything will remain as it is. So on opening the bracket, we have minus 1 and this minus 1 minus sign outside the bracket, minus sign inside the bracket, cos square A will become plus. Here you have minus 1 and this minus 1, I have cancelled it so that I can have more space in writing below. Cos square A is kept as it is, 2 cos A is kept as it is. Then this cos square A will remain as it is after opening the bracket. Fine. Now here just listen, look carefully. Cos A and cos A, these two. Cos square A and cos square A, they will get added up, and on adding we'll get 2 cos square A. So addition, then this 2 cos A kept as it is, and in the denominator 2 cos A sin A as it is. Fine. Now in the numerator you will have 2. So keeping this plus sign, on either side you have 2 and 2. Here we have cos square A and here we have cos A. So here we can take common, 2 cos A can be worked out as common. So when that is worked out as common, here we will get 2 cos A What remains here is just single cos, and on the right hand side of the plus sign we have 1. So nothing is remaining, therefore 1 is written. In the denominator you have 2 cos A sin A, and here this 2 cos A and 2 cos A in the numerator and denominator are cancelled. So what remains here is now cos A plus 1 upon sin A. Now split the denominator, cos A upon sin A plus 1 upon sin A. Now cos A upon sin A is cot A, and this is cosec A. So that will come as here cot A plus cosec A. And now this is the right hand side of your proof part. So this is your problem now proved. So in this way we have very lengthy steps. If you practice it again and again, I hope you will understand it properly. So simple methods are there actually, just to multiply, give the necessary effect and move on the problem. Fine students. So this was the same problem done for you in 2 different ways. So today we'll end up here. Thank you very much. So thanks for watching. You were live with Khandekar sir. If you liked it, just click the like button, subscribe to my channel Kit Classroom. Thank you very much and good night.